Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from energy control. The name of a topic is interchange evaluation with unit commitment. Now, extended interchange transactions requires that a model of a load to be served in each system. That is, what is the expected load level as a function of a time. When the load will be maximum for that particular period of a time, we know it can be drawn from the load curve. Let's say in between morning 10 to 12 or morning 10 to 5, industrial load is there, so the demand is more, like that. It can be included as well as the unit commitment schedule for each. Now what is unit commitment? Already we have gone through this concept. Unit is nothing but, we have to say here, unit is boiler plus turbine plus generator, and commitment means whether to turn on this unit or turn off depending upon some situations. The procedure for studying the interchange of a power over extended period of a time is as follows. First one, each system must run a base unit commitment study. So for each and every system we have to find it out first, unit commitment study. These base unit commitment studies are run without interchange. In a previous video we discussed that. Just we have to find it out, economic load dispatch for area A, then for area B, and then we combined it for utility A and B. Likewise, we have to find it out these base unit commitment studies without interchange. Each system will serving its own load. That doesn't mean the utility B's load will be imposed on utility A. No, we are going to find it out separate loading condition. Let's say from previous example, for utility A it was 700. So we will think about only that particular area with that load only, which is given by a load forecast extending over the entire time period. Each system then runs another unit commitment, one system having an increase in the load and the other there is a decrease in the load over the time period the interchange is to take place. Each system then calculates a total production cost. Now this is very important. In case of unit commitment, we have gone through two methods, priority list method and dynamic programming method. It is associated with your cost of generation only. So we have to find it out total cost of a generation for a base unit commitment and for the unit commitment reflecting the effect of an interchange. The difference in the cost for each system represents the cost of an interchange of a power. If you remember, in a previous example, we have seen such kind of condition wherever there was a difference in the cost, when it was not interconnected and when it was interconnected. That is, a positive change in the cost is nothing but it is used for selling the system, and whenever the negative change in the cost is there, then the system is going to buy the power. The price for the interchange can then be negotiated. If the agreed on pricing policy is to split the savings, the price will be set by splitting the savings of the purchaser and adding the change in the cost for the selling system. If the savings are negative, obviously it would not pay to carry out the interchange contract. The unit commitment calculation will allow the system to adjust for the startup and shutdown times to take more effective advantage of interchange of a power. Now we need to decide, these are the constraints that we have seen in the unit commitment. Some kind of time we have to given. If it is on, it should not be turned off immediately, and if it is off, then it should not be turned on immediately. So minimum uptime and downtime that we have seen, minimum on time. So it may pay for one system to leave an uneconomical unit offline entirely during a peak in a load and buy the necessary interchange power instead. Thank you for watching this video.